Hello everyone, welcome to today's video. This is a really exciting one. We're going to be talking about template matching. Template matching is a way for us to detect objects, the presence of objects, as well as the location of objects on the screen. This is integral to machine learning, AI, and botting. So this is a great tutorial. Now this is not going to be part of any series. I will be incorporating this into our other bot projects, but this is kind of a standalone tutorial and introduction to the method. Now, I'm going to be using a different game, a game that you've probably never heard of called Super Mario Brothers. We're going to be using this to demonstrate the concept of template matching. It's going to be extremely easy for you guys to understand, and it's extremely easy to program. So this is actually, despite it being a relatively complicated and complex operation, it's actually extremely approachable. And it's very, very useful, not just for games, not just for bots. This is an absolute critical thing if you're trying to do automation and you're trying to locate the presence of things and where they are. So this is a great tutorial for you to get involved with. Consider liking and subscribing. I really, really appreciate your support. So thank you so much for tuning in today, and let's get started with the video. Okay, so the first thing you're going to need is an image and some images that have been cropped or some things that are part of that image to work with for today's tutorial. So let me show you my example. So I have this screenshot from Super Mario Brothers, and I've got some objects here from the screenshot that I'm going to try to detect in game. So for example, I want to detect block, I'm calling this block number 1. This is kind of that hit, the block that's already been hit. I've got the standard bricks here. I've got the question mark block, and then I've got my Goomba. So we're going to demonstrate finding those as all individual separate objects in this scene. Now keep in mind that you could have more or less objects, but just get a couple of images, get an overall image and a couple of things from that image that you want to use for playing with. You're welcome to pull these images along with the code from the Git repository if you want to just follow along with the exact same images. But today's tutorial is actually very, very simple for us to program and implement. So really try to focus on understanding the concept, the conceptual thing of what we're trying to accomplish here. So let's focus on, let's think about you for a second here. If I showed you this question mark block and I asked you, where is it in this image? Would you be able to identify it? Obviously, most of you guys can, but why can you do that? Well, what you're probably doing is you're probably scanning the image subconsciously without even realizing it, and your brain is looking for patterns that match. And you see a pattern here, here, and here. Now, you don't actually know, if I zoom in on these, you don't actually know if this block is exactly the same as that block. You don't actually know if pixel for pixel. Now, of course, in Mario Brothers, because of the limitations, most of the things are identical. But in reality, you don't really know, and your brain doesn't even really care if those two objects are 100% identical, pixel for pixel, exactly matching this item here. What you know is that basically the pattern of that object basically matches the pattern of this object to a very, very high degree of confidence. And if you were to compare the question mark block with like this empty block over here, they're both blocks, but your brain can already tell, yeah, that's not as close of a match as this one over here. So that's exactly how template matching works. We are going to quantify a way to basically take a template and compare it with everything on the screen and come up with a number that represents how close it is to the object. So for example, if I'm looking for blocks that are empty like this block, this is a block, so this might be kind of related, but the green shrub should probably be almost not related at all, and the blue background should not be related at all. When I come to this guy here, well, this looks really, really close to this, so this should have a very high degree of confidence. So it's a statistical approach. What we're not doing is we're not definitely saying this is and this is not the object. But what we're doing is we're saying we're very confident that that is the object, and we're very confident that that is not the object. Just like, believe it or not, your brain does. You don't know if all three of these question marks are identical, and you don't really care. But you know that they're close enough that you're confident, you're willing to say, yep, those are 3 question mark blocks. And that's how template matching works. We're looking for things that are close enough to our template to say, yep, that's the object. So let's get started programming, and then we're going to look at the result of a template match, and this will start to make more sense. Okay, so let's get started using template matching. Now, template matching is going to be part of the CV2 opencv library. So we're going to do import CV2, which is Python's opencv library. Now, if you are not already aware, you can install that by using pip, Python's package manager. You're going to do pip install opencv-python, and this will install that package just in case you don't have that already installed. So the first thing we want to do is we want to read in our images so that, obviously opencv can work with them. And the command to do that is we're going to say our original, this is our original image, is going to be equal to cv2.imRead. This is image read, and we're going to put in our file name here. So just for convenience for the tutorial, I put the files right in the same folder so I can just use the file name. Keep in mind that if they're not in the same folder, you're going to have to put in the correct path here. So that will read the image. Now, I'm going to make a small version of this for display purposes, just so that it displays smaller, just so it's a little easier for us to work with when it's being shown. So we'll say cv2.resize, and I'll put in the image that I want to resize, which is my original image. For my size, I'm going to put in 0, 0, because I'm not going to specify a pixel size. I'm going to specify a ratio. So I'll say fx equals 0.5 for 50%, and fy, so y scaling, is 0.5. Okay, and now let's test that CV2 is working properly. So what I can say now is cv2.imShow. So this is going to create a window to show my image. And we need to give this first a name. We have to name this window. So let's call this original. So this is our original image. And we're going to pass in the small version of that. And then if we run this will display and immediately close the window. It won't keep it open for us. So that's kind of an annoying thing if you're just learning how to work with CV2. With opencv, see how it executed, nothing happened? It seemed like nothing happened. So we need to do a cv2.wait key, and we're going to put in 0. So this is going to stay open until we hit a key. 0 here is a time, but if you specify it as 0, then it basically is infinite until you press a key. So let's run this and make sure that, yep, so there's my original image scaled 50%, and it's in a window called original. And if I hit a key, that code will then execute. And what we can do is we can, it's always good to end your application with cv2.destroy all windows. That's just kind of a nice housekeeping thing, self-explanatory. Okay, let's go back up here. So we know that our CV2 library is working properly. Now let's also bring in all of our other images. So this is our original image. Now we got to bring in all of our templates. We want to create all of our templates. So we'll call block1, block_1 equals, and I'm going to do cv2.imRead, and we're going to put in the file name. So for me, that's block1.png, and I'm going to read in block2 is going to be cv2.imRead block2.png, and we'll say block3 and let's bring in our Goomba. So our Goomba is cv2.imRead Goomba.png. So I've got all of my templates in my original image now in opencv. Okay, next we want to create a template match. So to create a template match, we want to compare this with the original image, not the small one. We could compare it with the small one, but then we'd have to resize all these. It'd be better to resize them all so they're at the same scale. So let's just keep it simple. Let's work with this original image. We'll just display the small one just for convenience, for display purposes. So in opencv, we want to create a match template. So let's create it, and then I'm going to show you what it looks like, and this will start to make sense. So let's create block1 match equals cv2.matchTemplate. Okay, now first we want to put in our image, the image that we want that contains the object. So that's going to be our original. So this is our original image. Next, we want to put in the template image that we are looking for in that image. So in this case, we're looking for block 1. And finally, we want to use a method. So I won't get into too much stuff on the methods, but essentially what we're going to do is we're going to use tm underscore c coefficient normed. Okay, so what this is going to essentially do is create a normalized value between 0 and 1 of how close something correlates to our template. So we're going to look at the match template now. We're going to display it as an image, which it can actually be displayed like an image. And once you see it, you're going to understand what's happening here. So the block, okay, so now let's basically treat block 1 match just as an image. So we have our original image here. Let's resize this just so it's the same size as our small, just for right now. So what we'll do is we'll say block 1 match equals, we'll just overwrite it. Oops, CV2 dot resize. We're going to resize this. Again, we're going to put in our original image. We're going to say 0, 0 here since we're not specifying exact pixel dimensions. And we'll say fx equals 0.5, fy equals 0.5. Okay? So here's what we'll do. We'll display our original image. And we will also display our match template for block 1. So we'll call this block 1, or we'll call this match. And let's pass in block 1 match. Okay, so block 1, remember, is this one. It's the hit block. So let's run this code and see what it looks like. Okay, I'm going to move my match here, and I'm going to move my original image here. Okay, and the sizes are a little bit off. They're not going to be exactly the same size, so don't worry about that. But let's look at what's happening here. So what's happened is opencv has basically scanned this entire image, and it's looked for correlation between the template and what's on the screen. And you can see that wherever there's a very bright spot, that indicates a high degree of confidence. Again, this is all normalized between 0 and 1, essentially. So things that have the least in common with our template are darker, black. So you can see all this blue background. The thing knows, yeah, this has nothing to do with what we're looking for. Now the shrub down here, obviously to us, it has very little to do with this object, but it has more to do with the object than the background. Remember, everything is statistical. Everything is relative. Of course, the actual object itself is this nice bright spot. That means that the object we're looking for is here with a very, very high degree of confidence. But if you also look over here where we have other blocks, remember how we talked about even us, we can understand that those are kind of similar, but they're not exactly the same. Well, these have a higher correlation than a blue background, and they have a higher correlation than a shrub and a Goomba. So what we're seeing here is a statistical comparison of what we're looking for versus the world and what could be that object. So what is most likely this empty block is obviously the empty block itself. What is next most likely to be that? Well, the common sense, it's going to be these other blocks. They're kind of a similar color. They're kind of a similar shape. So you can see that, yeah, these are the next most likely thing. What's the least likely thing to be our object? Well, it's all this blue emptiness. So this is very easy to understand. Essentially, what we're looking through is we're looking at an image that is kind of an instantaneous snapshot of our brain processing what is most likely the thing that we're looking for. All this stuff in humans kind of happens instantaneously and subconsciously. When you look at this image, why do you know that's the object? Well, because it matches the template of what we're looking for. But if we could somehow take a snapshot of your brain and, analyze the data in the right way, we'd probably have a similar thing where it'd be like, yep, you recognize this as most likely the template of what you're looking for, but you also recognize that these have more to do with that template than the Goomba does, which has basically nothing to do with what we're looking for. So does that make sense? This is a statistical approach. So how can we use this map to determine if something exists? Well, we can look, are there any bright spots on the chart? And we can say if it's not above a certain brightness, we're not going to treat it. So we might say anything less than 70% confidence is definitely not what we're looking for. So we can basically take everything else and make it black. And we'd be left with maybe just this one bright spot. Or we might have more than one object. So let's look at another example here. Let's copy this code. So we've got our block 1 match here. Let's copy this, do the same thing for block 2 and block 3. So I'm going to quickly update this code here. So we've got block 2. Let's do block 3. And then let's do our Goomba. Everybody's favorite. We'll call this Goomba match. We'll put in Goomba match here. Okay, and then I'm going to copy this code here a few times, and I'm going to put in a wait key after each one so we can kind of step through them. And don't forget a wait key at the end or else it'll disappear on you. And we'll put in 2, 3, and let's do our Goomba match. All right, now let's run this. Okay, so we've got, again, this is our block number 1, which is our empty block. So again, this looks good. We are seeing that these blocks are kind of related, but this is a very high relationship. That is the object. Let's hit the key. Okay, now we're looking for bricks, and we see 1, 2, 3. So again, very high confidence that these are our brick blocks. But again, it kind of recognizes that this is kind of something that could be possibly kind of related, but very low confidence. And of course, everything else, very, very low confidence. Again, this is all statistical. Okay, now we've got our question mark blocks. 1, 2, 3. Perfect. So we're able to identify that we have 3 question mark blocks on the screen. Again, though, it's still able to see that, there's something over here that's kind of related to what we're looking for. And now let's try the Goomba. And here's our Goomba. So most of this stuff is all pretty dull, so it's pretty low relationship. And the only reason it's probably related at all is because the colors can kind of match, some of these browns. But again, very bright spot here. So it indicates, yep, there's one Goomba and he's located right here on the screen. So this is template matching. This is how this is what we can use to identify the presence of objects and the location of objects when we don't know where exactly they are and we don't know exactly what they're going to look like, but we have a pretty good idea. Now this won't work for things that are completely different and completely changed, but for things that are close enough that our brains can recognize patterns, we can do the same type of analysis with the computer. So I hope you found this tutorial interesting and intuitive, and I hope you now understand how you can apply template matching to your project. So again, consider liking and subscribing. I really appreciate you today. Have a great rest of your day. Thank you.